Hi, and welcome to our video series about biomimicry life principles. Life principles are design lessons from nature, and they can be found in all life on Earth. For each of the 26 life principles, we're going to show you an example in the ecosystem of a tree. And just like in nature, life principles are all interconnected. But so that we can understand them a bit better, they are organized into 6 master principles and 20 sub-principles. So, how does life on Earth do chemistry? We're going to be looking into 4 principles, starting with the master principle, use life-friendly chemistry, and 3 sub-principles, break down products into benign constituents, build selectively with a small subset of elements, and do chemistry in water. Our 4 examples for these principles in the tree ecosystem are the nectar that can be found in many flowers, the nectar that is offered by trees in return for pollination by insects, the venom of spiders and what happens with venom and poison, the fascinating process of photosynthesis using small subset of elements, and the principle of chemistry in water as in a tree system, water flowing through the tree, nutrients and sugar. So let's start with the master principle, use life-friendly chemistry. And our example here are nectar-producing plants, like a small-leaved lime, for instance, a beautiful tree. And the system of energy in return for pollination. A lime tree is pollinated by different insects, bees, for instance. But how does a plant attract insects? Because the plant, of course, wants the insects to come because they want to be pollinated. This is a very simple gift that the plants give the insects. Sugar. Sugar that they create in photosynthesis. And this simple sugar as nectar is offered to insects as a trade-off. I'll give you my sugar and you'll take the pollen from my flower to the flower of a different plant. So this sugar is basically the friendliest substance that we know for life. It's the basis of life, created in photosynthesis. What's our design guideline here? Use chemistry that supports life processes. And this system of nectar for pollination is found in many ecosystems of trees. Many trees are pollinated by insects and offer nectar. Break down products into benign constituents or into benign components. And our example in nature are spiders and the poison that spiders have and how they deal with that. So most spiders are venomous and they use their venom to paralyze or kill their prey. And then they inject chemicals into the victims so that basically their body becomes a kind of fluid and the spider sucks the fluid out. But it also sucks the venom that it injected itself into the victim. But it doesn't harm the spider because the spider uses chemical substances as venom that disintegrate very fast and actually break down into benign components that are no problem for the body of the spider. And actually the components that the venom is broken down into are now important for the metabolism of the spider. And this is a fascinating principle in life that we can find anywhere, not only in spiders. There are very many poisonous animals or plants, but the poison that is used in nature is always gone very quickly. It breaks down naturally in natural processes into components that are life supporting again. Our design guideline: use chemistry in which decomposition results in no harmful byproducts. In our tree ecosystem, spiders, of course, are found everywhere. You can find a spider web somewhere in between the leaves or in between some branches. Spiders are running around on the soil. Important predators for insects. Maybe they eat insects that the tree doesn't want to have around the leaves, for instance. So insects and spiders, both of them very important in the ecosystem of a tree. Build selectively with a small subset of elements. And our example in nature are autotrophic organisms, or the process of photosynthesis, the basis of all life as we know it on Earth. In photosynthesis, carbon dioxide and water are transformed. They're transformed into sugar and oxygen. And this is on the one hand, extremely complex process, but basically fundamentally simple, and it uses just a small amount of elements. All you need is carbon, hydrogen, oxygen, and those three elements make out the vast amount of organic chemistry. And in photosynthesis, it's this special transformation: water and carbon dioxide into sugar and oxygen. And when we breathe, what we eat, when we breathe, what happens in our bodies is exactly the opposite. It happens in plants, it happens in animals, it happens in fungi. Sugar and oxygen are changed into carbon dioxide and water. This is the yin and yang of life, the chemistry of life. What's our design guideline? Assemble relatively few elements in elegant ways. And of course, photosynthesis is the basis of all life on Earth as we know it, and the basis for our ecosystem of the tree, because it is the way that the tree actually creates sugar and creates food for itself and for all other organisms. Do chemistry in water. Our example, of course, again, is the tree and the xylem and phloem. How is water transported in a tree? How is water used as a solvent? It doesn't matter if it's about nutrients. The tree needs nutrients from the soil, and the tree creates sugar in the photosynthesis, which it needs to transport into all of its body. And the solvent that is used for all of these transportations is water. The nutrients are solved in water, the sugar is solved in water. And through the system of xylem, the water and the nutrients are transported from the roots up to the top, and through the system of phloem, the sugars are transported all through the body, from the top down to the bottom. What's our design guideline here? Use water as a solvent. And this system of water as a solvent is the reason our ecosystem of a tree can be alive and healthy. This is how the transportation system and the metabolism of every living thing that we know works. The tree itself, of course, but also that is the reason why an aphid can drink the sugar with the water. That is the reason why fungi can live in cooperation with the roots of the tree and exchange water and nutrients and sugar. So that was part 6. To get the whole story, check out the other 5 videos about the life principles and our video, What is Biomimicry? See you next time.